Hello, everybody. Welcome to our lecture for Wednesday, March 8th. So here's the plan for today. We're going to begin by reviewing our two different bonding models that we've seen so far in our class, which is the Lewis model of bonding, which we practice when doing our Lewis dot structures as seen in our chemical bonding workshop. And we're going to compare that to our kind of first, more advanced, I would say, bonding model, which is valence bond theory. And I call it a more advanced theory because what valence bond theory does that Lewis does not is it takes into account the fact that electrons are quantum mechanical particles and are best described by the orbitals that they are occupying. So we're going to get into that review and also a comparison of the two first in today's lecture. And once we're kind of conceptually situated in the difference between the Lewis model and valence bond theory, we're going to go over some key points of valence bond theory that were introduced on Monday. And one of those key points of valence bond theory is this concept of atomic orbital hybridization. So we are going to look at hybridization a bit more in depth today. We're going to look at some specific types of hybridization, specifically first sp3 hybridization. Then we're going to look at sp2 hybridization with a focus on kind of more simple molecules, meaning ones that don't form double bonds. And then we will look at sp2 hybridization where a double bond is formed, otherwise known as a pi bond. So we're going to get into all of this, and I hope that what you'll find is that this lecture really meshes well with the second day of our chemical bonding workshop where we looked at our molecular geometries, because VSEPR theory is really just an extension of valence bond theory. So I will see you in part one where we review our two current bonding models as seen to date.